we show an LCD-based display that supports not only multi-touch, but also off-screen interactions. We call this a bidirectional screen, or BiDi Screen for short. Although many techniques have been developed for providing multi-touch and 3D gestural input to displays, the BiDi Screen is a solution that can be manufactured in a thin, portable package, image objects while determining their distance from the display, and requires minimal additional componentry as compared to LCDs already slated for mass manufacture. Our technique is inspired by a new generation of light-sensing LCDs being developed by manufacturers such as Sharp and Planar. These LCDs have a light-sensing array of pixels. The light-sensing array has been added to provide economical multi-touch input for the display. However, these displays as currently conceived can only image the surface of the display. A finger is in sharp focus when pressed against the screen, but the image quickly blurs when the finger moves away. We show that by slightly displacing the light-sensing layer from the LCD, we can use the LCD to modulate the light reaching the sensor layer, and thereby sense depth as well as position. If we simply display a pinhole array on the LCD, hundreds of tiny images will be formed on the sensor array, each from a unique perspective. By analyzing these patterns, we can decode depth, creating 3D images of objects in front of the screen without requiring direct contact. Due to the lack of development tools for light-sensing LCD displays, we simulate the sensor plane using a diffuser screen. An ordinary video camera simply observes this diffuser. The LCD of the BiDi Screen works in two modes. In display mode, we turn on the backlight and display the input image. In capture mode, we turn off the backlight and we display a pinhole array pattern on the LCD. The sensor plane records the image. Since the backlight is off, the user does not see the pinhole array image. A pinhole array is just one of many masks that can be used to image the scene onto the sensor array. A tiled Mura code passes more light to the sensor array while preserving the imaging abilities of a pinhole array. We alternate the LCD between displaying an output image and forming the mask for light field capture. Here, we show a touch and then hover interaction, first from the user's perspective, and also from the various stages of the image pipeline. The raw data imaged by the light sensor has been modulated by the mask displayed on the LCD. This image can be decoded into a light field image, which is equivalent to an array of low-resolution cameras distributed over the LCD surface. By segmenting individual depth planes, we can recognize free space gestures. Once again, we show the user's experience. Our goal is to enhance interfaces with the ability to sense off-screen interactions. We demonstrate 3 simple proof-of-concept interactions. This first demonstration was initiated with a touch gesture to select one of several models. Once selected, the model can be manipulated with touch-free hover gestures. The bar on the left side of the screen indicates an estimated distance between the hand and the screen. When a touch event is detected, the bar turns red. The model can be rotated along 2 axes by moving the hand left to right and up and down. Scaling is controlled by the distance between the hand and the screen. Touching the model again puts it away. A virtual world is explored under control of the BiDi Screen. In this demonstration, the avatar is controlled using a hand held in front of the screen. Moving the hand left to right steers, up and down controls gaze, and reaching towards or retreating away affects movement. Because touch is not used, this demo is particularly suited for public spaces where communicable illness may be of concern. In this demonstration, a simple 3D graphical world containing a bronze sphere and a plastic cone is interactively lit using a virtual light source whose parameters are controlled by the light striking the BiDi screen. Although our focus is on enabling the technology and not on novel interaction design, we hope our work will inspire LCD makers, as well as interaction designers, to think about new opportunities in light sensing displays.